In this video, we'll be talking about breathing volume. Just to recap of the last video, we discussed the importance of the process of breathing and the muscles involved in both passive and active inspiration and expiration. In this video, we'll be going into lung volume, lung functioning, and how it's being measured through spirometry. So in this video, we'll first cover spirometry and relate it to lung volume. We'll then define residual volume and compare lung volume in different groups of people. So what is a spirometry? A spirometry is a breathing test that uses a spirometer to measure lung volume and how well your lungs are able to move air in and out. It is a quick and simple method used to assess lung functioning and can help to identify many conditions, such as asthma. And now we'll have a demonstration of a subject performing a spirometry test.
So just a couple of normal breaths to start. Perfect. Normal breathing. Normal breathing. We're just getting a baseline here, so that's perfect. Nice and relaxed breaths. Okay. So big breath in. Fill those lungs up, 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 and slowly blow out. All the way again, keep pushing, keep it going, still some air coming out, keep going, keep going, keep going, keep going, keep going, keep going, and hold your breath out there empty just for a couple seconds, hold it empty, 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 and breathe in, and take the mouthpiece out. Perfect. Okay, great.
So here's the screenshots of results with labels, showing normal versus maximal inhalation and normal versus maximal exhalation. Now we'll go into what they represent. And these will be tied with lung volume. When we're looking at graphs, it's always a good idea to know what the different axes represent. We can see that the y-axis on this graph represents the volume of air in the lungs, and the x-axis represent time. Therefore, this graph shows how the volume of air in our lungs changes with time. The first section of the graph represents the tidal volume. The tidal volume represents the volume of air that moves in and out of lungs during normal breathing. Therefore, the highlighted section of the graph, presenting the tidal volume, is the amount of air we breathe during passive breathing. Now we can see the next section of the graph. The person was asked to take a deep breath, and the volume of air has increased beyond the normal breath. This extra volume of air is known as the inspiratory reserve volume. Together with the tidal volume, the inspiratory reserve volume is the amount of air we breathe during active inspiration. This combined volume is highlighted on this graph. Now we can see the last section of the graph. The individual is asked to breathe out more than their normal breath. This extra amount of air that's exhaled is known as the expiratory reserve volume. And the tidal volume plus the expiratory reserve volume is the amount of air we breathe out during active expiration. Again, this total volume is indicated on this graph. So we'll define what is a residual volume. The residual volume is the volume of air that remains in your lungs after you breathe out. During normal breathing, there will be 40% of air that will remain in your lungs. To make the concept easier to understand, we'll use a balloon analogous to our lungs. As we're seeing in this video, the balloon is releasing air, which is analogous to the expiration in our lungs. And there's some air remain in the balloon, and it's analogous to the residual volume in the lungs. And when we move on to active breathing, there will be smaller amount of air remain in your lungs, thus you have lower residual volume. And now we will move on to lung volume comparisons in a normal person, an athlete, and a person with asthma. Please keep in mind that they all have the same total lung volume. What changes is the amount of air that can move in and out of the lungs during breath. The basic concept here is that the athletes tend to have greater amount of air that can be inhaled and exhaled during active inspiration and expiration, which is also shown during exercise. Having more oxygen will enhance their performance. Their chest muscles are also stronger, allowing them to expand their chest more in order to increase the air intake and to contract the chest more to exhale more air. So it is the increase in the efficiency of the lungs, rather than changes in the size of the lungs, that makes the athlete perform better. Another example is with asthma, a very prevalent lung condition that makes it difficult to breathe for those who have it. When we compare the lung volume graph of someone who suffers with asthma and to a normal person, we can see the amount of air that's blown out by the asthmatic person is much less than a normal person in the same amount of time. This is because the airways are more narrow in those who suffer with asthma, so there is more resistance and difficulty in exhalation, resulting in less amount of air being blown out. In summary, we have the most amount of air blown out by an athlete and the least amount of air blown out by a person with asthma. And this can be demonstrated from this demonstration. As we can see, the person with asthma has much less amount of air blown into the balloon than a person who's an athlete. In summary, we introduce spirometry and see how it can measure the lung volume, and we compare that the person with asthma has much fewer exhalation than an athlete. Next time, we'll talk about breathing while sleeping.